Welcome to the introduction video for our new and exciting Conditional Gaussian Simulation course, which is part of our Geostatistics course series offered by the geoRGB community since early 2021. In this course, we aim to provide students with a practical understanding of conditional Gaussian simulation using R and QGIS software, and why and when it can be preferable to Kriging interpolation. Get ready to get informed of the essential lessons of this course, designed to give you a clear and direct understanding of environmental projects and decision-making processes. In Lesson 1, we will introduce Gaussian Anamorphosis, a vital data transformation technique in geostatistics that standardizes datasets by converting them into a Gaussian distribution with a mean of 0 and a standard deviation of 1. This normal distribution is crucial when working with conditional Gaussian simulation, a fundamental method for modeling spatial data, as it enables more accurate assumptions about the data's statistical properties. By applying Gaussian anamorphosis, geostatisticians will be able to enhance the accuracy and reliability of their simulations, leading to a more precise representation of spatial patterns and well-informed decision-making in the field of geostatistics. In Lesson 2, we will delve into simple Kriging, an integral geostatistical interpolation technique that forms a key component of the conditional Gaussian simulation. This lesson will highlight the importance of simple Kriging in spatial prediction, and the essential step of reversing Gaussian anamorphosis to obtain predictions on the original value scale. By understanding and implementing simple Kriging within the framework of conditional Gaussian simulation, we will be able to generate more accurate and reliable spatial models, ultimately enhancing our geostatistical insights. In Lesson 3, we will explore the advantages of using conditional simulation in geostatistics. We will dive into the practice of generating multiple realizations, thereby deepening our understanding of this powerful simulation technique. Furthermore, we will discuss the benefits of employing conditional simulation over traditional estimation methods, highlighting its role in capturing uncertainty and providing a more comprehensive representation of spatial data. In the following lessons, we'll engage in hands-on exercises demonstrating the application of conditional simulation in environmental projects for informed decision-making. The exact number of practical exercises is yet to be determined, but we currently have 3 planned. One focusing on creating maps that show the probability of soil contamination, another on evaluating the costs of a soil remediation project, and a third on assessing the uncertainty of water table levels in a groundwater well installation project. Stay tuned as we release these lessons on our website at geescourse.online over the upcoming months. Don't forget to subscribe to our YouTube channel to follow along with this exciting course. In this course, you will gain a comprehensive understanding of conditional Gaussian simulation, from its fundamental principles to its real-world applications in various fields, such as geology, hydrogeology, mining, remediation, and so on. By the end of this course, you'll be well equipped to model spatially correlated variables, enabling the quantification of uncertainty fields. With multiple realizations of a spatial field, you'll have a more comprehensive understanding of the underlying processes and be better prepared for informed decision-making. We hope you are as excited as we are to embark on this journey to master the art of conditional Gaussian simulation. Join us now and enhance your geostatistical expertise.